All right, so let's take a look at question number 3. Now we're rotating the region about the line y equals -3. So the line y equals -3 is beneath both of our functions. Okay, so we have, let's say we have the function, the region like this, and then y equals -3 is down here. Okay, so the two functions, or the three functions you're looking at, are above this function, the axis of rotation. So we're going to be using formula number 1. Okay, as indicated in number 2, the location of the axis of rotation determines which of these functions you select. So let's go ahead and list the functions that we need first, and then we apply to the formula. We have to look at two regions since our bottom functions change from region 1 to region 2. Alright, so our answer, our expression for the volume, will be a combination of two distinct integrals. Okay, now for region 1, what are our limits of integration? It's just like number 2, we're going from 0 to 2. Our function on the top of x is still root x. Our function on the bottom in terms of x is equal to 0. Okay, is the x-axis for region 1. And then our axis of rotation, a of x, has now changed to -3. Okay, so this is the region we're looking at right here. Region 1, this is the function on the top. Function on the bottom is f of b of, oops, not wrong color. So f of b of x for region 1 is equal to 0. And our axis of rotation is somewhere down here. Okay, all right, so we have everything we need to generate the expression for the volume of rotating region 1 about the line y equals -3. Let's shift our attention to region 2. For region 2, we have x equals 2 to x equals 4 as our limits of integration. Function on the top is equal to still the same function on the top. Function on the bottom is now different. That's why we had to break this up into two distinct integrals. Okay, function on the bottom with respect to x is equal to x minus 2. And then the axis of rotation, a of x, is equal to -3. Okay? Alright, so now we are set to create our volume expression. I'm just going to apply these values to the formula 1. Okay, so let's go ahead and do it. So the volume is going to be pi. This is for region 1, okay? Integral from 0 to 2. Integral from 0 to 2. So pi r square, we want to figure out r square of our outer disk. So we're going to have, let's see, function on the top, root x, minus the axis of rotation. Now the axis of rotation is -3, so -3 just changes this to a +3. Okay, so +3. So this is the radius of the outer disk. So pi r what? Pi r square gives you the area. Okay, so pi r square. Now we need the area of the inner disk. Unlike number 2, there is an inner disk here. Okay, so it's going to be minus the inner function. Oh, I'm sorry, function at the bottom. So also the inner function is 0. Minus the axis of rotation again, so +3. So this is pi distributed here, pi r what? Pi r square. That gives you the area of an inner disk, right? So when you subtract inner disk area from the outer disk area, you have the area of the washer, all right? And then when you integrate it from 0 to 2, that gives you the volume of region 1 when rotated about the line y equals -3. So that's for region 1. Plus, now let's shift our attention to region 2. Pi from 2 to 4, limits of integration have changed, times the function on the top minus minus the axis of rotation. So minus the axis of rotation, minus makes this a plus 3 because this is negative 3, so minus minus 3 makes it a plus. So pi r square for the outer disk plus the inner disk is going to be the function at the bottom. Function at the bottom is x minus 2 minus the axis of rotation. So it's going to be minus times another minus, makes this a plus 3. And then you close that, this is pi r square, close the integrand dx. Okay? So function on the top minus axis of rotation, function on the bottom minus axis of rotation, square square. Okay, that looks good. Function on the top minus axis of rotation, function on the bottom minus axis of rotation, square square and a pi. Good. So just you can always go back to your formula and make sure everything lines up perfectly. And it does not. Small mistake here. This is supposed to be a minus. You're supposed to subtract. So that it's going to be a minus. Okay, so this is a minus. So outer disk minus inner disk, outer disk minus inner disk, and then combine the two solids, and then you're done. Okay, so it's really good to check your answers to make sure that is in fact correct. So this is for number 3. Now let's take a look at number 4. Now for number 4, we are rotating it about the line y equals 4. So what's the situation here? Now for y equals 4, what's happening is our axis of rotation is now on top of the two functions. So what's the significance of that? Well, that now means we're going to be using the formula on the bottom. Okay? Everything is going to be similar. The only thing that's going to be different is the axis of rotation and the formula that we're going to use. Okay? So for number 4, it's going to be somewhat similar to number 2, number 3. So for number 4, let's go ahead and determine what's in each region. So for region 1, and then for region 2. So for region 1, limits of integration remain the same. X equal to 0 to x equals 2. Function on the top, in terms of x, is equal to root x, like number 3. Function on the bottom is equal to 0, just like number 3. Axis of rotation is now 4. That's what's different. Okay? And then for region 2, limits of integration is from 2 to 4, again, like number 3. Function on the top, function on the top is, in terms of x, is square root of x. Function at the bottom changes to x minus 2, like in number 3. And then our axis of rotation is also 4. That's different from 3, okay? All right, now we have all the ingredients. We're going to be using this second formula here because the axis of rotation is about the two functions, okay? So now let's go ahead and apply it. We're going to have the volume, pi. Now we're going to start with region 1, from 0 to 2. The formula says we have to go axis of rotation minus the function on the bottom. All right, so that's what we're using. Axis of rotation is 4 minus the function on the bottom. What's the function on the bottom? 0. Okay, that's the radius of the outer disk, pi r square, minus area of the inner disk, axis of rotation again, 4 minus the function at the top. Function at the top is root x. That's r, pi r square. So square that. Close your integrand dx. This is the volume of the solid generated by rotating region 1 about the line of y equals 4. But we also have another region which we must include. So integral from 2 to 4. Using the same formula, but on region 3 this time. Axis of rotation comes first, minus the function on the bottom, not top, function on the bottom, which is different now. We have to remember to put our parenthesis, x minus 2. This is the radius. Okay, so let's not forget our pi r square, pi r square. Okay, you want to go over that to make sure that you don't make mistakes. Minus the function, I mean the axis of rotation again, minus the function at the top. So this is the radius of your inner disk, your smaller disk, okay? So how do you find its area? Pi r, this is the radius, square, area of a circle, pi r square. Do that check. Dx, squiggly brackets to close the entire integrand dx. And that basically is the volume of the solid generated by rotating region r about the line y equals 4. Okay, so to really help you understand it, you can compare 3 and 4 and see how they basically look different as a result of the order of the axis of rotation and the function that we're using. Okay? All right, now let's shift our attention to question number 5, which is the y-axis.